Test, test, test. Now it is. We are just figuring out the last setups here because we need to make sure that I actually can click on the button for the next slide. But it's all set up. We are all here, and congratulations to you all. You made it to the most exciting and important session of this day, I would say. So thank you for being here, although you're not many, but I think we're going to have a very, very nice session with all the speakers upstairs. Quick words on my side. My name is Franka Kunz. I'm working for ESA, and I'm part of the Destination Earth team. And today's session is really about the sectorial impacts. Let me check how the session was called, Connecting DestinE with Sectorial Applications. And we know that this is a very important topic because, of course, we have the digital twins. We have the very high resolution impressive models. We do have large data sets. We have very nice services already. But all the backbone and all the capabilities we are producing in DestinE needs somehow to be connected to some end users. Because we need to make sure that what we are doing is actually useful for all the end users in their daily work life. Because I don't know from your side, at least me, I don't wake up in the morning saying, oh, I need a high resolution, nice digital twin to solve all of my problems. This is usually not happening. Usually you wake up, and especially the ones who are working in the impact sector, they need to really solve problems. What is happening to my crops in the future when there's more heat stress on the crops? What is happening if I have more heat island and more heat waves in my city? What happens if the air quality is bad? And so on. So this is something we would like to look into. So we have 4 presentations. And we have 3 presentations on really impact. We have 1 on air quality, 1 on agriculture, and 1 on health. And then we have a bit of a, I would say, exotic presentation in this session, which is about co-design, because this is actually bridging the gaps between all the technical and scientific work we do to the end users. And we also want to look into this. But enough from my side, because it's much more important to hear from the speakers itself. And I would like to start with Sarah. Sarah is the lead of Amigo, an Italian small SME. And she has a long experience also in climate modeling. And now she's connecting her knowledge really to the impact sectors and really to the users. And she will tell us today how this will look like. So Sarah, please.
So thanks a lot. Thank you for the introduction, Franca. And thank you everybody for being here after lunch. So I will try to keep you awake. So I'm really happy to start a discussion on how DestinE can support policies for agricultural resilience at EU level. So why agriculture? Agriculture is tightly linked to climate, and climate is changing. And we see the impact. In the last decades, agriculture registered a constant trend of 6% of increase in economic losses. And this impact is particularly notable for perennial agriculture for 2 main reasons. First of all, perennial agriculture is particularly lucrative. And the second reason is that you need time and resources to implement adaptation measures. So we have an emerging risk, and we need new solutions. But most of the climate service users, I'm talking about 80%, they ask for high-resolution data to really look into local details. So what can we do with DestinE data? I'm giving the example of SIT, that is a contract funded by ECMWF as part of the DestinE initiative. It started more or less 1 year ago, and we are halfway. And it's a consortium led by Amigo with 6 different partners. What are the key features of SIT? So first of all, the service is co-designed with stakeholders in agriculture. By now, we already engaged more than 100 stakeholders. I'm talking about a variety of stakeholders. And what we did was a structured approach. So we started with a focus group to really understand what are the risks to focus on. Then we used a survey to demonstrate the large applicability of the method. And then we continued with the usability workshops and with detailed interviews to demonstrate the goodness of the information. We work towards a European coverage, but we started testing and demonstrating the solution on 2 case studies. The first one in Trentino in Italy, which is a mountainous area, and the second one in the Hardanger Fjord in Norway, so also there, very complex terrain. And the other key feature, of course, is high resolution data. So we start with climate ET, and then we also apply downscaling reaching 50 meters resolution. So what we provide a user is the whole path from data to action. So we start with the climate DT. We focus especially on apple and grape wines. We analyze 4 major hazards. We have heat waves, drought, excessive rain, and late frost. And we link this hazard to the phenological phase that is exposed to such an hazard. So then we combine all this information to identify areas that will become not suitable to a specific crop in the future, or areas where we have growth opportunities that might also happen. And with the information, we make the next step, so we try to understand what we can do to adapt to climate change. So we have a portfolio of adaptation measures and a framework to analyze them that is aligned with ESG pillars. But now I want to show you exactly what I am talking about. So here you see the platform. So the first thing you see is the suitability map. So here you see how different areas are suitable for grapes in present-day climate and how this will change in the future. So now I'm moving to future climate. And then we can also change crop, and we can look more specifically into apple. If you browse over the platform, then you see more details, but you see even more details if you click on a specific point. And then you have the whole phenological cycle and how this shifts in the future. So as we can imagine, it's getting warmer, so you have a shift backwards in time, so everything starts earlier. So what happens is that you are exposed more or less to specific risk. And then we have extra information on the hazards we are considering with specific indicators. So you see we have heat waves, and then also, I mean, if we scroll down, then you see excessive rain, and you see the frequency, how it is expected to be in the future, but also how it changed with respect to a reference period. For some hazards, we have also specific information, not only on the frequency, but also on the intensity. So here, this is a specific example for late frost. Okay, so now we know, we have a bit of an idea what our risks are, what is, we have assessed that, so we want to know what to do. So this is a complete, quite a comprehensive list of adaptation measures. You can scroll down, of course, but we just click on one of them to see what you get. So you have this card. You see, first of all, on the top right, you see what is the hazard you're mitigating, then you have a short description. You see what is the time horizon, because for some adaptation measures you need more time for implementing than others. You see how effective it is to mitigate the risk. And then you have on the right-hand side this analysis following the ESG pillars. So how impactful implementing the adaptation measure is with respect to the environment. What are the economic and non-economic costs? And how aligned it is with current policies. So basically, the idea is that you have a comprehensive overview of the different adaptation measures and you can prioritize them. So to conclude, I want to go back to the initial question. How can DestinE support EU policies for resilient agriculture? That's my personal view. So we have available innovative, high-resolution, authoritative data at high resolution, which is already very important, especially if you think of heroic agriculture. Here I put two photos, two pictures of our two case studies. So you see the Dolomites, you see the fjords, so very complex terrain, very complex situation. We have a framework for operationalized climate service development and provision, and we have also opportunities like this one to strengthen and expand the existing EU community on climate tech. So thanks a lot. If you want to test the solution, just come to demonstration 6. And if you want to let us know what you think about the solution on the basis of what I just showed, please use this QR code. Thank you.
Thank you, Sarah, and a big applause for your presentation. And just to let you know, we're going to do questions afterwards. We do all presentation first, then we're going to have a short discussion, and we also let you ask questions afterwards. One thing I would like to highlight is actually also because we talked in the preparation is what it's actually nice to see that you're originally funded from ECMWF budget and how to apply these digital twin data in a real context. But this service is already available on the DestinE platform for everyone to use. So it's not just that it was funded, it's now available. You can go there and you can explore. And it will stay there for a while and hopefully evolve also. And I know that because we discussed beforehand, there's a lot of apples. It's not just one sort of apples, there's a lot of apples to look into. So it's really complex and also impressive how many end users you needed to engage with. We will look into this a bit later. Thank you so much, Sarah. We are now coming to the next presentation to a very well-known friend, which is Anna from Plus Atlantic. If you're part of DestinE from the beginning, you probably know her because she is also part from DestinE from the beginning. She's calling herself a climate and EO architect. And she told me that this should be everything I should say about her, which says everything. And she will talk about health and impacts on the health sector. So please.
So thank you very much, Franca, for such very nice words. And thank you for the DestinE team involved and all of the E's and the DGs involved on this very dreamy initiative which kind of is helping me fulfilling some of my dreams. I'm a bit nervous, as I usually am in these DestinE events, because it matters to me. So apologies if I stagger a little. Today, I'm going to present you a project that is funded by ESA, not exactly inside DestinE itself, but rather from the Digital Twin Earth Initiative, which is a side program from ESA that aims to maximize the results that we can achieve with this DestinE initiative as well, using ESA funding. So in this case, this is a consortium for an early DTC or early digital twin component. The project is led by Plus Atlantic, in which I take part of as lead. And it's a collaboration between GMV, which you already know probably well. It is a company on the space sector, and the Faculty of Medicine in Lisbon, who do all the health park and have a long track record in tackling health issues and implementing the surveillance system that we have in Portugal. So to whom? I would start with the users, because I feel that now that we are moving into the third phase of DestinE, it's all about the usage and the adoption. And concerning health and climate, the trigger for this project was actually the identification of a need. This identification of a need comes from the fact that in Portugal, and this is a project that is about Portugal but has implications at the European level, as you will see or recognize, in Portugal the seasonal surveillance system is pretty much labor intensive in the sense that it's not a digital tool. It does not offer climate outlooks, and it basically results in a PDF file that is sent via email, manually put together by some human resources. And I often take this tale that my sister, she's a medical doctor, and she receives often the bulletins some days after the heat waves actually occurred. So in Portugal, we do not yet have a digital system, a digital twin, if you want, for short-term forecast, rather alone for climate projections. And this was the trigger for the identified need. As you can see, and that is a survey from the users, it was corroborated early on by strong discussions with all of the stakeholders involved to map these needs that we perceive to exist and that they confirmed. And what we want to do with this project is to basically streamline, using DestinE tools and data, everything together in a digital, efficient, automatic, although supervised way. So we want to have the data being pre-computed, sent automatically to the stakeholders, and there are more to be tackled than the ones already involved in the system. Make the calculations for the excesses, the actual impacts, not only the hazard, but the impact itself in terms of mobility and morbidity, and actually send out automatically via email, via cell phone, whatever there is. But more than this, we want to build a dashboard, a digital twin-like interface, in which not only the first responders can get access to, but also my mother, my uncle, my sister, everyone from the community. So something oriented for the citizen. So this is our mapped users. We want residents, we want health practitioners, but also municipal agents, because often the first responders are at the municipal level rather than centralized in the national health system. So moving forward, with whatever we have already implemented in Portugal, but most countries, the when is already pretty well tackled by the Met services and the CMWF. The best models are in Europe, as you well know, in terms of short-term forecasts. So the tricky part here is that we do not go up to the where. So what we have currently, and this is the case I believe in many countries, is that we have an early warning system that gives up an alarm that is the same throughout the country, even though when we look at the mortality and morbidity patterns, that's not the case. They are local specific. So the objectives were the digitalization I already talked about, and the second is to improve the resolution. So we can summarize that technical part as a downscaling exercise. So how do we do it? We are using AI and machine learning for cost efficiency, also because we want something that is fit for purpose, and many of these institutions do not have HPCs to run very heavy numerical prediction models, so we want just to pick up the best that we have in terms of the when, and this is supported, as you saw today, by European institutions and Met services, and go up to the local scale in a cost-efficient manner that is scalable as much as possible and fit for purpose for the community outside of the climate and the Earth observation experts. We are using Sentinel-5P as one of the co-response variables along with in situ observations. So ground truth observations, either direct or remotely acquired, is our response variable, and we use AI and machine learning techniques to bias adjust these mesoscale models to the local scale, along with high resolution Earth observation derived products like land use land cover, tree cover density, imperviousness, and others. We always benchmark our models against traditional regression-based models to make sure that we have the best tool at the minimal cost, because we only need to use big AI models whenever the precision surpasses that of the regressions and traditional ones. So going forward, this is the results, and I can brief you after this session on the techniques. Basically, this is the downscaling from nitrogen dioxide. This is what we are able to achieve, and I would highlight not only the resolution that you can clearly see from the COMS data, so the mesoscale data that we already have at 10 kilometers to the 1 kilometer scale. Of course, more details are perceived, but what's more important for us is that for us to establish the epidemiological relationship between the exposure to the excess and the outcome, we need to, as much as possible, reach the values of exceedances that we see in situ. And if you look at the table above, you can see that in situ, from 2013 to 2023, we had, I cannot see from here, but 20,756 exceedance episodes in the in situ stations, but COMS only predicted more or less 9.5%, which is expected, is a mesoscale model. But then if you look at our downscaling approach, we are correcting this, and we are reaching the 20% that was in the beginning our target. So this is what we are offering. It's just not it's not a question of a pretty high resolution map, it's a question of precision. We do the same with ozone, even though for ozone, because it's not a local specific permanent pollutant, but rather a secondary one, in these images you probably cannot see as much the gain in detail that there is, but I can show you afterwards bilaterally if you need. But we also improve the percentage of exceedances that we tackle, and more importantly, if I go next, we can see that the spread, the spatial spread of the exceedances is different between the 10 kilometer and the 1 kilometer. So you can see that some situations, because in the end for public health is a binary decision, are we or are we not under exposure? You can see that prior to downscaling, there is a bigger area that is under-predicted. And this is, let's say, our target for improvement. With this, we then map per municipality the values weighted as a function of space and population, and we do these compound event risk factors. This means that if we have a heat wave alone or ozone exceedance alone, we will have one level of risk. If we have them together, and depending on the intensity, this level of risk is multiplied. The reason why it's tackled like this, it's based from the response function that we acquired, and these are the results. Per heat wave in Portugal, we have almost 2,000 excess mortality along 3 to 5 days, but more importantly, not more importantly, but as importantly, we have 10,000, for example, excess hospital admissions, and this poses a burden on the emergency services. We are talking about excess hospital admissions due to several problems. This is the all cause, but we are fine-tuning the models per each major diagnostic group, per each age group, per gender, and all of these confounding factors because the relationships in terms of lags are not equivalent across all. As I said before, this compounding factor comes from the epidemiological model itself, which you are now seeing some of the results, that prove that heat waves contribute 2/3 to the outcome on all-cause mortality, while ozone exceedance contributes with 1/3. So this is a sum, in this case, it's not a multiplicative equation, because by trial and error, this was the model that had the best results on withheld test data. And this is how we compute the compound risk per municipality that you saw. And what we proved from this is that actually the compound risk is local specific rather than national-wise. And when we use the national-wise, we are usually under-predicting the excess mortality and hospital admissions at the local level. Now, the next step, and you are now seeing some mock-ups, is the development of the tool itself. It's pretty much inspired by dashboards that you probably saw around during the COVID, and this was designed according to the functional and non-functional requirements mentioned by the users themselves early on in the project. It's very simple to use. I can show it to my mother and she can use it. It's not a complex web GIS system, but it's all there is need. And even though it's very simple, the science behind is actually pretty complex to reach the precision that we need. But in the end, it's like we need to do this very long journey to improve the precision, improve the reliance, to then come back to simplicity, but it's a simplicity that is grounded in accurate results. And with this, I conclude my presentation, and I'm happy to take any questions later. Thank you.
Thank you, Anna. And thank you for highlighting how complex everything is. How many data sets you need, how many things you need to combine to get these results. And just maybe 2 words on, this is funded, as Anna said, out of the ESA DTE program, which is a program which is fully supporting DestinE. It's ESA member states money. We fully support DestinE, and we are developing digital twins in addition to the DestinE digital twin, and especially in these impact sectors where it's so important to have more digital twins in the future. It's not yet in the platform because it was basically done that we showcase how many things need to come together from a scientific perspective, but it hopefully will be available. And we also hope that it will be scalable to other countries. Because as you can see, it was only Portugal and Spain, but there's a lot of potential also to scale it to other countries. Thank you very much again. So we will come to the next presentation, which is also related to air quality. And this is a small change because you, in the program, you probably saw the name Karine. It's not Karine, but it's not a problem because it's a perfect substitution because it's Olivier. Karine has something important to do today, but she sent Olivier, and I have to read that, is the head of the Emission and Air Quality Modeling Department at Air Paris. And they're really working on regional emission inventories, air quality modeling, and really with basically also warnings they have to do and to improve the air quality for Paris. So they are not yet, I have to say that, part of DestinE. So they are not part of any consortium. They're not developing anything for us. But we know that air quality is a huge topic, and he agreed that he's going to present how and some ideas how he could connect to DestinE. So, Olivier.
Good afternoon, everyone. So I'm really happy to be here and to have been invited in that event. It's a great opportunity for us to participate. Today, I would like to talk about something that takes place at the intersection of science, technology, and public responsibility, that is integrating air quality needs into Destination Earth. So I represent Air Paris, which is the air quality monitoring agency for the Île-de-France region. And what I want to share with you today reflects not just our technical perspective, but the very real operational and regulatory obligations that agencies like ours face every day. So just a quick start about the context. In France, air quality monitoring is defined through the 1996 French Air Act. Under this legislation, independent regional organizations are accredited by the Ministry of Environment to carry out monitoring across the country. Air Paris is the organization responsible for the Paris region. And what makes our model unique is its governance structure, as our boards brings together state representatives, local authorities like the Paris municipality or the Paris region, industry and economic players, and also experts or NGOs. So our core missions cover monitoring, public information, and support to decision makers, with a special focus on the intersection of air quality, climate, energy, and health. So how do we actually monitor air quality? The answer is through a hybrid system. There is not a perfect tool. We rely on several tools. The first one is a reference monitoring network, which is done through static stations and also on field campaigns. The second tool is the emission inventory, which is really important for us. In our emission inventory, we rely on real-time traffic data, and we rely also on the third tool that are modeling platforms that are able to produce short-term forecast and are able also to map high-resolution air quality. We can reach 10-meter resolution over the Paris area. So the system is also enriched by satellite data, by meteorological models, and it relies also on specific environmental and geographical data. So this system is permanently evolving, as there are new pollutants that should be addressed, new levels are defined, and also we have to integrate all the new technologies like IoT or artificial intelligence, and also improved satellite coverage that constantly reshape what's possible. So why does all this matter so much? Three main reasons for that. First, we have legal constraints. Air quality is not a purely scientific topic, it carries legal weights. So EU directives set binding limit values. Member states and local authorities have to face court cases brought by European Union, by national courts, and increasingly by citizens or NGOs. So this is a politically visible issue. The second is public health. Air pollution are direct and multiple impacts on health and mortality, and particularly for vulnerable populations. And environmental inequalities are stark, and the economic and social costs are really important. Third, mitigation measures. Cities are deploying low emission zones, traffic restrictions. There are also regulations on heating system or on industries. These are strongly linked to the energy transition and climate change agenda. So as a result, all this impact cities' attractiveness and competitiveness. So we clearly need operational, robust, and faster tools to support all of this. And here lies the gap. So on one side, the left side, we have remarkable scientific capabilities, satellite observations, high-resolution modeling, powerful HPC infrastructures. On the other side, our operational needs are clear. We have to update our short-term forecast, for example, for ozone episodes. I will focus a little bit later. Better understanding of long-term ozone trends and much faster policy assessment tools. So Destination Earth takes place in this space. The question is how to bridge the gap effectively. So this is where the opportunity lies. DestinE brings together three powerful assets: digital twins of the Earth, high-performance computing, and AI capabilities. So for us, there is a clear translation into concrete potential. We can, for example, investigate an integrated air quality and climate digital twin at city scale. We can imagine real-time scenario testing for support policy design, or we can build also improved data assimilation systems in order to combine satellite data and ground-based observations that could be based on a reference network or on microsensors, for example. So here is a specific example which deals with ozone, tropospheric ozone. Ozone is the only regulated pollutant that has actually increased in the recent decades in urban areas. So it's both an air quality and climate pollutant. Its behavior is complex because it depends on chemical regimes and it depends on the balance between NOx and VOC's emissions. And furthermore, is strongly influenced by hemispheric background transport. Climate change is making things worse, even worse, as there would be more heat waves and higher temperatures. It could involve more frequent episodes. So we'll investigate all these questions in the framework of the Cosmos project, in which we'll use the CAMS global reanalysis data in order to model all the atmospheric composition from 2003 to 2023. And we'll also investigate the impact of public policies on ozone levels. We'll investigate the use of YASI satellite data for trend analysis, and we'll also investigate the impact of ozone on crops in collaboration with a research institute responsible, which is involved in agriculture. Our second major need is speed. city planners and policymakers cannot wait weeks for having a response to city scenarios. So we need answers in real time. So the concept we are developing an AI surrogate model based on deep learning emulator trained on chemical transport model outputs that can map, link the city scenarios to the air quality concentrations for example, PM10, PM2.5, NO2, or ozone, and also to address population exposure. So within DestinE, this could be embedded into a true city-scale digital twin with the city as a subsystem of the climate, of the regional climate and atmosphere, with multi-sector coupling, mobility, energy, vegetation, urban heat island, air quality, and population exposure, all co-simulated. So the scenario axes we are working with span 4 key dimensions: sustainable mobility, based on the encouragement of multimobility or or active transport, climate change adaptation through urban greening and cooling strategies addressing urban heat island, building renovation, environmental equity, because the burden of pollution is not equally distributed, and public policy must address those disparities. So to conclude, I want to present this as a call for integrated collaboration. We need to scale up our existing capabilities, and we want to be able to implement them at effective operational tools. This requires cross-domain integration. We need to connect research with operational monitoring and science with the design and testing of public policies. And there are also real opportunities here in Europe. Air quality is a critical issue in many developing countries, and in the current geopolitical context, it's also a matter of environmental science diplomacy and an opportunity to promote European solutions. Finally, a word of caution: we must be mindful of the energy consumption associated with data centers and AI-driven solution. This is clearly not an abstract concern. It's already a preoccupation within our community. So thank you very much, and feel free to connect with me in order to discuss.
Thank you, Olivier. And thank you also to highlight the sustainability aspect of DestinE. It's also a topic for us. Also on the platform, we will have a dashboard monitoring on all the pollutions and CO2 productions we are already having, because we know this is a topic we need to look into also with all the AI topics. Also, thank you for your huge wish list. I hope that we all going to listen to this and remember what is on your list. And it's great that you agreed that you will be part of the session, and I hope we can have more discussions in the future with you, because you're somehow an end user of DestinE. You also have more end users, and they are very, very important. And it's also nice that you highlighted that there's a huge gap between the like what we are doing and the end users. We do have a solution for this. At least, let's say, we did a nice document on how to solve this problem, which is called the co-design methodology, which was funded out of the DestinE program. And thank you, Olivier. And now that's why I want to bridge this gap between the sectorial applications, but also to bridge this gap really to talk about how we can use co-design to actually create something very useful for end users. And it's very good that Patrick agreed to have this presentation right now, because it's, as I said, a bit exotic. But Patrick will talk about, he's from the Federal Agency for Cartography and Geodesy in Germany, so he's also a public authority end user. They also have more end users, and he will tell us about how we can use the co-design methodology and how they would like to use the co-design methodology to better connect everything. Patrick, we know each other for a long time. You have a PhD in remote sensing, so you also have some, I would say, scientific background, and now you're working also on stakeholder engagement, and yeah, we'd like to see what you...
Yeah, thank you, Franca. And let's start with the exotic part today. My plan for the next couple of minutes is to share our journey on how the Destination Earth co-design methodology can be practically applied within the context of our digital twin project in Germany, focusing especially on our stakeholder management. But before I will dive a little bit more into that and into co-design, let me give you a brief overview about our project to provide some context. Our project, the Digital Twin Germany project, was started in 2022 and was expected to be finished by the end of 2026, which is this year. Our goal is to provide a comprehensive simulation and analysis platform tailored for federal administrations across Germany. And to achieve this, our project consists of three components, major components. The first component is the development of a cloud computing platform. The second one is the development of a databases. And this databases includes a three-dimensional data set, which we are acquiring at the moment exclusively for the entire country for the first time. And the third component is the implementation of use cases. And this third component is exactly what brings me to the topic I would like to talk about today, about stakeholder management, because stakeholder management is really essential in this component. When we launched our project, we started with a couple of pilot use cases. For most of them, we were asked to take our 3D point cloud coming from the LiDAR point clouds and extract objects from it and feed this information into a workflow tailored to the demand of various federal authorities, such, for example, tree crown inventory or the derivation of flight obstacles. And to manage these demands, we established a specific stakeholder workflow, and it looked like this. We started with an idea, then we had an initial contact, then followed by a demand-oriented workshop. We defined a proof of concept, established corporations, and worked in partnership in order to deliver the final application. However, when we scaled up our stakeholder management, we were focused with four major challenges, and these challenges are the information gap. So mostly the value and the benefit for most of the potential users and stakeholders is not always clear. We have a commitment issue. Starting with a high initial interest often does not translate into active and sustained collaboration. Then we have a resources problem, meaning that the stakeholder engagement tends to decline after this initial phase of enthusiasm. And we have a lack of agility, the processes that we have are documented well, but for long-term adoption, it remains challenging to address the changing needs. And looking at this situation, we realized that we could not be alone in this. Many others must be facing the same challenges. And that reminded me of the co-design concept, which was initially developed in the eShape project, and which is now being applied to the Destination Earth. environment. And yeah, after taking closer looks at the documents, it became clear that these difficulties we are facing right now are completely typical for a reactive co-design method. And yeah, recognizing this helps a lot because it shows that it is a structural issue, and meaning we need to structurally adjust our stakeholder management to move forward. Let me tell you a little bit more about the reactive co-design, because it has not only challenges, it has limits. And these limits are that if you are coming from different fields of expertise and different focuses, you often speak different languages, and these different languages are creating gaps between capabilities and needs. And we have the linear feedback trap that if you are giving reactive feedback, it will create feature lists, but it is not really a co-design. And we have the scalability wall, meaning that reactive approaches fail to scale beyond these initial plots. And the prototype bias, meaning that if we involve the users lately in the process, it will lead minor not to structural changes. Okay, and the solution is we need more proactive and structured co-design. So we have to strategic cluster the stakeholders by expertise, background, and focus. We should provide customized engagement where we have tailored communication channels, workflows for each specific cluster. We have to come from the reactive to the more proactive and long-term adoption. Yes, and as I mentioned, our idea was to use the Destination Earth co-design methodology, which I was continuously tracking since 2019. Yes, as I said, coming from the eShape project, and now is established in the Destination Earth context. And yeah, this co-design methodology is providing interesting tools that can be adapted to our workflow. And while we were analyzing our current workflow, the workflow I showed a couple of minutes before, was showing that this workflow, our initial workflow, was useful for our 4 pilot use cases, but it is no longer sufficient facing. At the moment, we have about 30 potential stakeholders, and it will be even more in the future. So we have to somehow make a transition from our stakeholder management and into a more structured approach. And herefore, I was very happy to have contact to the developers of the Destination Earth co-design methodology this spring. Yes, but for those of you who do not know much about the Destination Earth co-design process, very, very brief, in I think 20 seconds, I will show you how it works. In this workflow, we have 4 phases. Phase 1 is the user approach. We have a diagnosis phase, we have a co-design session, and we have outcomes. And our workflow in the Digital Twin Germany project and the workflow of the Destination Earth co-design, I was trying to bring together, and I was identifying phase by phase that we are already doing some of these issues that are mentioned there, but we could also improve our stakeholder management by, for example, in the phase 1, we could add tools like stakeholder cards, stakeholder radar, in order to have a more fundamental approach. Phase 2 was totally missing or is totally missing in our workflow. And phase 2, the diagnosis phase, is really important. For phase 3, we are already running workshops. However, we could adopt findings from the Destination Earth co-design, for example, for workshop best practices, templates for better capturing the user needs. And the fourth phase, as well here, we are also doing something which is more or less comparable to this phase, but again here, the Destination Earth co-design also has or offers some tools mainly to sustain relationships over long term. And the most critical, it comes, the most critical thing was that the Destination Earth co-design diagnosis phase 2 was entirely missing, and this should be fit somewhere between the first contact and our first workshops. Yes, and this brings me to the outlook. We see that during the analysis that we have to readjust our stakeholder management. And what we identified so far is that the grouping of stakeholders is very promising. We have to set up clear roles, and as well we have to set up clear rules for coordination and communication. We have to create a clear feedback and a decision process. So in total, the integration of a co-design as a regular part of the development process in our stakeholder management is essential. Thank you.
Working now. Thank you, Patrick. Thank you very much with this exotic topic, but thank you for highlighting that it's also important to have a structured approach to co-design. And I'm German, so I like documents, I like structure, so we needed to formalize everything to make sure that you all have what you need in the end and you can read it. So there's several documents out there to read, but we also have an AI assistant very soon, which helps with all of that. But we know that it's important to talk to the users, and it's nice that you highlighted how difficult this can be in the process and you're missing. And I know from Sarah and also from Anna, you are talking a lot to users, and you're probably facing the same problems in the end, that what you're doing, they're not adopting it, they're not using it, and it's a lot of work. It's a lot of work to really talk to the end users and to design everything according to their needs, because if we don't do it, we fail in the acceptance of Destination Earth. Is there any question from the audience to one of our 4 speakers? Anyone? Yeah. Do we? Yeah, she's coming.
Hi, thank you. Bente Liljaby, BLB from Norway. I was an advisor to the eShape project, so I'm very happy to see that you are using it. And I have a question concerning how the stakeholders were responding to the process. I'm referring to some frictions, both by the technology, those who are developers, and also the time needed by the stakeholders to invest in it. So any experience that you can share with?
Work? Yeah. Sorry, but I don't really get what... Because it's really challenging,
Yeah,
the
it's
acoustic
really
here.
hard to understand up here. It's super weird.
Should I keep it? Do you hear me better now? No? Do you hear me better now?
Let's try.
Yeah, okay. The question is, how did the stakeholders find time to engage in the processes? Did they have to have good, was it any frictions, any difficulties from the stakeholders? And the second question is, how about the developers, the technical people? How did they find this process useful?
You mean the technical experts within our house or from the stakeholder, because it depends. Because in our project we are coming from a federal agency for cartography. We are geodata experts, and all these technical and expert knowledge behind the different use cases is coming as well from the stakeholder. So this is what I was trying to say with the resources problem, that it's often a problem that even if we would have resources in our house, we have not the expertise, and the expertise is with the federal agencies in our case, who are having the demand and they don't have resources. So yeah, it would be better if you would have some funding that you can say, here you have a great idea, here you have some money, and so you can establish resources in order to fulfill the needed work.
But I think it's very useful also to hear from Sarah and Anna, because they don't use this methodology, but they use a lot of co-design. And I mean, as soon as you were with the end user, it's interesting. So maybe you have it.
Yeah. So what I would say is that about like friction or potential issues, we were really lucky, so to speak, to have authoritative partners. So a lot goes through networks. You really need good connections to keep this engagement. Plus, you need, well, this is maybe a bit outside of your method, but to kind of select the first users. You need somebody that is really into innovation, so that they are ready to take this, and then you can scale it up more to a larger audience. At least that's our experience. Otherwise, you have really large initial barrier, and it's really hard to identify the needs. And concerning the dialogue with technical people, that's a good one. I mean, I think you need somebody that is really bridging between the two, right? Going back and forth, because I think for technical people, like these things are fascinating, but they are, of course, really into their topic and they like their things, so it's hard to step forward. And for the users, it's really, okay, but I need this, I don't care what to do. So it's a lot of fun, let's put it this way.
Oh, thank you, Franca. Yeah, this one is working. So on our side, working on compound extremes and health, because it's on the public side, the friction point, it's probably like this in almost every sector, but what's in it for them? So the difficult part is to sell to them what's in it for them that makes them move from what it is, the current status, to something that will entail effort. So there has to be a gain, either a reduction of costs or an improvement of profit. Here is not business profit, but notoriety profit or whatever. And from my perspective, in the health sector, fortunately, and this is why I love this sector in particular, because we are talking about the public good and everyone wants to have a healthy life and to live very long, people tend to come together, and it's a bit more easy to bring consensus and to sell to them the idea of co-ownership, because when we talk about compound events, we have to have on board both the public health, the national weather services, the national environmental monitoring services, and they have different mandates. So this is a shared partnership, and all of them have to work with each other with similar, as much as possible, speeds, with compatible requirements. And the way I have seen working best in this domain is to have this kind of concept of a B2B2C business model, so a business to client model, which translated into the public sector means a requirement that is between the innovation sector, the public ownership sector entities, these public entities at the national level, but that in the end fulfills the requirements from the public. So the requirements in the end come from the public and the citizens themselves. And since we are running almost out of time, I don't know if there is many of the DG people in the room, But I would say that on the DG side, I was really, really happy to see yesterday several DGs here in the room, and I hope that we can bring more, particularly those related to cities, to health, because in the end, I think that if we put that out in the open, that there is a lot in it for them all, because of the capture of the citizens, then there is a strong willingness for adoption, and we don't need that much money if you think about that we can move adoption through regulatory and, I'm missing the other word, but regulatory and policy making incentives, like stick and carrot. There are smarter people in the room than me that can go in that direction. Thank you.
And thank you so much. You hear the gong, 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 and I also see someone waving from the back, so we need to finish up. And I saw there are several questions left. So the one who were asking these questions, you are more than welcome to directly approach Anna and also Sarah and ask these questions. But thank you for listening. Thank you for being part of the session, and we wish you thank you to all the speakers again, and a nice rest of the user exchange.